We're now going to consider some of the factors that go into movements of real GDP away from potential GDP just at the start of a recession or the start of a boom. It's the first step, if you like, of these departures of real GDP from potential GDP. And we'll see one of the things that is important in considering those first steps is something they'll call the consumption function, how much consumption reacts to income in the economy. We want to trace out that connection in the consumption function for these first steps of real GDP away from potential GDP. So let's consider an example to get started. Let's suppose you had to forecast what next year's GDP would be. We know that the movement, if it's going to be up or down away from potential GDP, is going to be related to demand, aggregate demand, as we discussed last time. Well, aggregate demand can be obtained simply by adding up what people are spending: consumption, investment, government purchases, and net exports, C plus I plus G plus X. So you could just add that, get surveys of how much people will consume next year, surveys of how much they're going to invest, etc., and make a prediction of what total production would be just by summing up the estimates from those surveys of C, I, G, and X. And that may be a guess of what your level of GDP will be next year, your forecast. Now, there's a slight problem with that. It could be significant from time to time. If you don't take account of the fact, if you don't watch out for the fact that consumption, in fact, depends on income. The more people have in terms of income, the more likely they're going to spend. If their income goes down, they're probably going to spend less. We don't know exactly the amounts, and the amount by which they spend more or less could be unstable or could change from time to time. But nonetheless, there's going to be a relationship. An example of that relationship could be that C, consumption, is 1,000 plus 0.6 times Y, income. So that would be an example of a consumption function. And when you think about that, the reason why you have to be careful is that if you were going to predict that GDP goes up next year because of a guess of consumption, investment, government purchases, and net exports, and you ignored the fact that that higher level of GDP would mean higher income and therefore more consumption, you might go wrong. And so what we want to do is analyze this impact effect, or this effect of Y on C, that must be taken into account when you're trying to forecast what Y will be. Now, to see the implications of this dependence, we first want to put on the back burner what's determining investment and net exports in the short run. We'll come back to that, but first let's focus on just this dependency of consumption on income. Here's an example of this dependency. It's an example of what economists call the consumption function. It has income rising, 1,000, 2,000, 3,000. In this example, in the second column, and in the first column, it has consumption rising. And this is just a table that represents that same algebraic formula that consumption is 1,000 plus 0.6 times income. So, for example, if income is 1,000, then your consumption would be 1,000 plus 0.6 times Y, or 600. So that would be 1,600, and so on down this. So you have the numerical example, you have an algebraic example, and then finally you have a graph, which tells you the same exact thing. In this case, in the graph, we're going to put income on the horizontal axis, and we're going to put consumption on the vertical axis. The line is drawn there. It's just another way to represent the table and the equation. As you can see here, there's a slope to that consumption function. It tells you how much consumption rises when income rises by a certain amount. That slope is called the marginal propensity to consume, MPC. And in our numerical example, in our algebraic example, that MPC was 0.6. Okay, so it's pretty straightforward. It reflects a fairly important regularity that as people get more income, they'll consume more. Now let's sort of take that and try to analyze the impact of that in terms of the departures of real GDP from potential GDP. Well, we have to be sure when we make our forecast for next year, maybe there's a recession or a boom, we don't know, but when we make that forecast, we have to be sure of two things. One is the income in that forecast should depend on consumption. And remember, income equals spending. That comes from a basic accounting identity in the economy. What people spend, people have to produce, and that's their income. So the first is income depends on consumption, or in equation form, Y is C plus I plus G plus X. So income depends on consumption. It's part of the spending which generates the income. You could call that the income spending identity. Don't really care what you call it, but it's an important thing to keep in mind. The second is that consumption depends on income. Or an equation form, C equals 1,000 plus 0.6Y, or the graph we've seen, or the table we've seen. This is the consumption function. So both of these things have to be holding at the same time. In simple terms, we have two equations. And we have two unknowns. The unknowns, represented in the red colors, are Y and C. They're kind of the variables that you have to figure out, must satisfy both of these relationships. You can think that I, X, and G, black letters, are on the back burner for now, and so what we're interested in determining is C and Y. What economists have done is, rather than work in terms of these two equations, they changed the second equation around a little bit, which gives some more intuition for what's going on, some better idea for what's actually going on in reality. So let's look at that adjustment. They modify the second equation by adding investment, government purchases, and net exports to the consumption function. Okay, and when they do this, they'll get the total sum of spending, which will also depend on income because consumption depends on income. And they call this total sum, economists call this total sum, the expenditure line. So let's see how this works. This is a graph which you can begin by looking just at the line at the bottom labeled consumption. And on the horizontal axis we have income, which remember is the same as GDP, real GDP. And on the vertical axis we have spending. That's the total amount spent on GDP. So the line at the bottom is just the consumption function again, no different from what we just looked at with our numerical example or algebraic example or in this graphic example. But to get this model to work, economists are going to add investment to this line, and there you see in the picture how investment is moves up the line, up by this amount here. And so it takes you to C plus I, okay? It's a parallel shift because we're assuming the same amount is added to consumption at each level of income, just an additional amount I. And then we added to that, we add in government purchases, so that raises the line again. It's in a parallel form because the same amount is added at each level doesn't depend on income, each level of income. And then finally we add in net exports X, and again it's a parallel shift because we're having net exports not depending on income in this example. So the sum of this is C plus I plus G plus X. That's the line at the top. We'll call that the expenditure line because it's the total amount of spending, expenditures in the economy. So it's really not telling you too much different, but it gives you a nice graphical relationship which we can use to figure out what's going on. And to do that, we're going to introduce one more idea, and that these lines shift up and down depending on what government purchases and investment and exports are. So I think from the previous graph, it's easy to see if government purchases rise, that curve's going to shift up, as in the arrow pointing upwards. Or if net exports rise, it's going to shift up. There'll be a larger shift. The larger are the changes in those. Similarly, over on the right, the arrow is pointing down if there's a shift down in government purchases or net exports or investment. And one thing that's added here is the variable T, which is taxes. And the idea there is that if people have more taxes taken out of their income, then they will consume less. So if taxes fall, they'll have more after-tax income and their consumption will rise. And so over on the left, you see the arrow moving up. It's a shift up in the expenditure line because the government is taxing less. And similarly on the right side, the downward shift could be taking place when there's larger amount of taxes taken out of income. So those are shifts in this expenditure line. And then finally, let's combine this line with the idea that income must equal spending. That was the other relationship that we looked at. That's our second relationship. And we can graph this quite easily too. Same diagram, income on the horizontal axis, spending on the vertical axis. And if income's got to equal spending, then it's got to be on the 45-degree line, because that tells you if spending is at A, then income must be at A. Or if income is at B, then spending must be at B. That's the 45-degree line. And so now what we want to do is combine this relationship with the expenditure relationship to get a prediction of what's going on, and really our analysis of the first step of real GDP departing from potential GDP. So you put the expenditure line on top of the 45-degree line, and you get something called spending balance. Again, the axes are just the same as before. And what spending balance tells you is that both relationships are holding. The consumption function, and therefore the expenditure line, the green line, you're on that line. You must be on that line because that's what the behavior of people is going on in that line. That is, consumption is depending on income along that line. But you also have to be on the 45-degree line because at any point in time, income must be equal spending. So this is a point of spending balance in the economy, and it must occur. It's a consistency that must take place in any analysis or in any model. You can give a numerical example of this as well. That's what this table tries to do. So over on the left, you have income or real GDP. Remember, they're the same. And then in the third column, you have consumption. Those are the two relationships that we began with. Now, consumption depends on income. So you can see as income rises, consumption's rising. That's that old consumption function again. And then on the columns to the right of consumption, we have investment, government purchases, and net exports. And in this analysis, they're on the back burner, so they're not changing. It's the same amount at each level of income. That's the reason for those parallel shifts in the line. Investment is 900 at all those levels, or government purchases is 2,000, and net exports 100 at all those levels. So we just add those, investment, government purchases, and net exports to consumption, and we get the aggregate expenditure, which is the second column. And what must happen in the economy is that expenditure, total expenditure, aggregate expenditure, whatever you want to call it, must equal income. And you can see in this picture that occurs at 10,000. If you're at a level of income below that, say 6,000, then income is less than expenditure. So that can't be the case. And if you're at a level of income above that, income is greater than expenditure. That can't be the case either. So the only place where there's consistency is at this line. And of course, that's the line that's associated with the intersection of the two curves. Now, let's go to work with this a little bit and sort of analyze what would happen about our forecast for next year. So what I've done here in this picture is taken the expenditure line, and it's represented in light green, and put it next to the 45-degree line. And now I want to consider, suppose something happens in the economy. Suppose government purchases decline. And in this picture, that's represented by a shift down in the line from the light color to the dark color. It shifts down by 100 billion in this particular case. It's a parallel shift down, less government's purchases at each level of income. So our prediction is that the spending balance in the economy will move from there, where GDP was at that level, and we'll come down to here where GDP is at that level. So we predict that GDP falls as a result of that decline in government purchases. And this, again, is occurring in the short run. It could be related to what we think would be happening next year if we knew government purchases would decline. Now, one thing that's very important about this, not only are we predicting that there'll be a decline in GDP due to this reduction in government purchases, we're predicting that it's a larger decline because the arrow pointing in the horizontal direction to the left, this arrow here, is longer than that arrow there. So there's a larger decline in income than there is in government purchases. And that's because, of course, the consumption depends on income. So you could think about it either in terms of this graph or in terms of looking at the equations again. Here's an example where you could have an increase in the aggregate expenditure line going up, or you could have a decrease going down. And you could think about a rise in real GDP as moving to point D, which would be a fall, or you could think of a change in real GDP as moving to point E, would be a rise. And in both the cases, we're imagining this is occurring because of some kind of a shift in aggregate expenditures, which in turn translates into a change in real GDP as shown on the horizontal axis. The takeaway from all this is that the change in the economy, like in a recession with the dotted line or a boom in the dashed line in this picture, relative to potential GDP, is that dark line relative to the dark line is potential GDP. So we're thinking in this theory there are these departures. And we're thinking as the departures is due to a change in demand. And if the change in demand is due to, say, a change in government purchases, we need to take into account that consumption will also change as we change government purchases. And that's why the impact is larger. That's why there's an extra size. Sometimes people call that the multiplier effect. A change in government purchases will lead to a change in income, which changes consumption, which changes income again. That's the multiplier effect. So we're taking these into account as our first step in analyzing what's going on. But I want to stress that those departures from potential GDP, the dotted lines or the dashed lines, they're just really the first steps towards a recession where it goes down or a boom where it's going up. It's really just the first steps. It's the very short run. It's the recession itself, say. We now want to see what happens that's to stop that decline or stops that increase and really gets it to turn around again, to come back towards potential GDP. And so for that, we're going to have a full model of economic fluctuations, and that's what we're going to do next. Thank you.